This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, good afternoon, good
evening,
whatever, wherever you are, the day after, but more about that at the very end of our podcast. Good morning, Robert.
Good morning. Let's start with a soap opera from the Silicon Valley. We will do that at the end of this news part.
Right.
But before we are focused on industrial AI, you were at the machine learning week in Berlin last week. What was your impression? What did listeners miss?
What did they miss? Or what did they like? I'm not sure what they missed. To be honest,
what did the listeners miss?
Yeah.
Listeners.
Who
was not there?
I don't know. We're going to talk about in 2 days. Is kind of looking backwards if we could do differently. I'm not sure that people missed anything. I think it was a great conference. I mean, there's always 3 different tracks. I moderated the Poor Industry 4.0. It's how it's called, for predictive analytics world. Is the smallest of the other. The other 2 is the business, and there's a tech, which has been called deep learning track. So no, it's very interesting. Many friends of the Industrial AI podcast. Will did a keynote. Will van der Aalst, he was with us, process mining.
Yeah.
And then directly afterwards, I did an interview with Hans Uskoreit from Nionic. We may quickly chat about that later. I'm not sure we're gonna do him. We'll chat. We'll talk about that later. It was about LLMs, and then Annemarijke Schlinkert was there, federal machine learning. Arzam Kotriwala, you recall you did the interview from ABB?
Yes. The autonomous, what was it?
Remote operator.
Remote operator, right.
Yeah, right. Michael Huff was there, causal AI. Causal is a big topic. You recall we discussed it yesterday as well, right? As we were in a video call. So Causal was there 2 times. Actually, the second time, let's say that immediately, from Maxim Sipos. He's from Causal Lens from the UK. And I requested to do an interview with him for the podcast.
Okay.
Alexander was there, Munich Re with Daniel Dilmetz.
Ensure AI, okay.
Yeah, de-risking machine learning in the car industry. And then our friend Franciscos.
Franciscos. Yes, greetings to Linz. Yeah,
he is going to talk in January, right? At our German language-based AI in industry for Hannover Messe, and that's where he's going to have the wonderful title. You recall?
Is it AI or is it for the trash or something? Yeah,
something like that.
Yeah.
This time he talks about predictive maintenance for dialysis machines, so a more serious topic. That is most certainly not for the trash can, right?
Yeah.
So many other presentations, very interesting. Yeah, it's an amazing. It's a very high level, around 200 people. Typical, since many years, data scientists come together and exchange their knowledge.
And what was when you look back, what was the most impressive presentation, Peter?
That's difficult to say. I don't have one just
when
at hand.
You close your eyes, and what do you see then?
What do I see when I close my eyes? I'm not going to share. No, really, not one of them pops up. But I must say,
the interview with Hans.
There you go. That was the first thing that came up, and that was not because there were 2. I mean, Hans was in parallel with Will, so I didn't see his. But we had a very, very nice interview. So looking forward myself to hear that again in the next couple of weeks.
Okay. So I was at the SPS in Nuremberg. I did the industrial AI part, so PLC drives and stuff like that. AI was also a topic there, especially in the form of LLMs. Everybody now wants to go into this LLM teamer. They were very popular with the audience. And Siemens and the Beckhoff showed a few things. For example, how you can build an HMI with an LLM. That was really impressive. I talked to a friend of mine, Tom Cadera from Cadera Design. They are designing HMIs and stuff like that. And he was also very impressed with this new technology. And we will have further episodes on this. And Bosch Rexroth also relies on LLMs, so you can't avoid the LLMs also at the SPS.
It's one of the typical use cases where and even Sam, just to mention his name, and I was going to talk about the first OpenAI Dev Day anyway, and that was a demo, and I'm not sure that he was doing, but other people have been doing it. But that was even before. I believe, was that the visual or is that now when you do a quick sketch and you show it to whatever, ChatGPT, any LLM, I guess, capability is going to be there in general. And in the background, there's going to be, I guess the code is being produced for you. And whenever I discussed it, that was also in Berlin. And then the people who are used to writing the code, that is their theme, right? The theme is the code is going to be written for you, or you're going to be help writing the code. And I'm always at the higher level, which is where we are now. It's more like the code is in the background. You're not writing code, So you say, okay, here's the sketch. Produce it for me, and that's what's happening. And that is the amazing thing, right? By the way, you may want to share with for our friends that are not SPS is the German word for PLC, right?
SPS is the German word for PLC, right? The trade fair show is called SPS,
Yeah, and I think in the meantime they give it a different meaning, like production system.
Smart production.
There you go. That's what they kind of renamed the acronym. Sorry, I interrupted.
No, you're absolutely right. We need to explain, because we are in this PLC drives automation jungle world, and maybe our listeners are not much into this. So the SPS is a trade fair show, and SPS is a PLC. But there was also another AI topic. Our friends from Keber, from Austria, it was very interesting because I want to discuss this topic with you. They presented its AI development kit. The dev kit consists of a Linux-based Keber controller, including I/O cards, and then the AI expansion to module. They call it module. And it's very, very interesting because it's difficult to sell AI in this field of industry. You still need your gray box to sell. You need a gray box, or your PLC, or your edge computing, or your EPC, and then you can sell AI. So it always comes together with an infrastructure or with a hardware product. That's interesting, and that was what I recognized at the trade fair show. So we often talk to startups. They have great solutions, and you mentioned Cthulhu, for example, federated learning, but they have not this gray box to sell. So the automation companies still need the gray boxes.
Sure, unless they do it in cooperation with, in this case, with Siemens, right? I mean, of course. I mean, they have been doing that for the last, 50 years, I guess. First PLC was, I believe, 1960 something.
Yeah.
I think it was from Siemens in Europe, or not sure if it was Rockwell or one of the other predecessors in the United States. So from that time on. And of course, in the meantime, we have other solutions like the Beckhoff PC based, and we're going to see what that means. If this connection, as you put it, is going to exactly stay like that, or if it's going to turn the other way around. Of course, we all know that the share of software is growing and growing and growing. But if you say, that connection to, buying a PLC box is still there, then let's see if that's going to change or not.
Yeah, and what I also recognized at the trade fair show, there were a lot of robotics companies this time.
Oh, right.
Yeah, it's totally unnormal for me to have a lot of Yaskawa, for example, was there. Oh. I was really surprised by that because the SPS, the trade fair show, is not specialized on robotics, but the whole topic automation shifts and together. Beckhoff has its own robot, and Yaskawa has its own robot, and very, very interesting. Yeah,
really. So maybe at the end, but we'll do it now, is because I'm at the very end now. Before I was going to share Microsoft, we'll come to them anyway, and Microsoft now doing their own chips. And that was the topic I was going to share with you and our listeners as well. So maybe you share with our listeners the history of the last couple of years of robotics on fair ground, because we have had, and you know that better, that's why I asked you. So we have had a new fair, a relatively new Automatica, right? Since when does that exist?
I don't know. Automatica was, first of all, the robots were in Hanover, at Hanover Messe.
Right.
And then there was this Automatica, and the new trade fair show in Munich. It was last year, the last turn. And now we also see the SPS with robotics. And then we see, for example, Logimat, that's a logistics trade fair show with robotics. And it's not an AI topic, but we always see, for example, at the SPS, we talk about software, infrastructure, AI, vision system, plug and play solutions, the software around connectivity between robots and other robot systems, the automation environment. So that's the robots are coming closer to the automation, and the automation comes closer to the robots. Right. So it's very interesting, and for sure there are AI topics like vision, cameras, and stuff like that, and how to simulate robots very fast and very easy. Yeah.
Right. So what about our main topic for today?
Exactly. The main topic is Deepmind's model and the ImageNet moment for robotics. Yeah, that's the topic. But I think it's a topic for the next 3 to 5 years, this Deepmind general robotics model. But I think it's interesting to hear for our listeners that there's a lot happening in the robotics market, and there's a foundation model and there are general models, and pretty interesting.
It's interesting you call it the ImageNet moment for robotics. That's very nicely said. Not sure you came up with that.
It's a quote from Abhinav.
Yourself doesn't matter, but it's amazing.
It's a quote
and that is in the interview.
Quote by Abhinav Valada. I did the interview with Abhinav, and he said that this is the ImageNet moment for robotics.
Because the ImageNet was really kind of not solved, but with the huge jump came with AlexNet, right? And AlexNet was co-written with a guy called Ilya Sutskever, and we'll talk about Ilya later on. He was kind of the very central person of our soap opera of this weekend, right? So I agree. I've seen I think that different people actually, so that's very good. Exactly looking at the use of large language models in robotics as well, right?
Yeah. What about the soap opera?
Let me share. I was going to share the first OpenAI Dev Day.
Sure.
Just want to very quick comments because we have many things today. I say, remember, it's only 10 days ago, right? That Sam did his first OpenAI Dev Day. It feels like a year has passed since then. There were so many announcements, right? And I think they were very impressive. Yeah. So if you, dear listener, haven't heard, still, nevertheless, independent of what has happened since then, you can still look at all the things that he has announced on YouTube. There's an hour, very impressive. I think it's very impressive. Now, the most important thing from my perspective, I think from most of the people who have commented, is that now you can build your own GPT, right? Now, let's see if that is still going to continue or not. That's another topic, but it's important anyway. No coding necessary. Again, sure, we've said it. English is the new programming language.
I don't know.
I don't know.
I think it was some Peter.
No. Oh, really? Oh, there you go. Just talk to your ChatGPT. Of course, we've been waiting for that, independent of if it's going to be called ChatGPT or Bing Chat or whatever we're soon going to call it. And then, of course, in combination with the GPT store, right? So your App Store, I don't know, what's the value of the Apple App Store? 100 billion or whatever, I guess, in the meantime. So, and then everybody agreed, in my words, that this is like a leap a big step forward for, at that time, OpenAI in general, big tech, I would say, and a step backwards for startups, open source. Not sure. I want to know from you how you see that. You also look at the open source community, because, then at that time, what was announced by Sam was taking a lot of the capabilities that startups, specifically / open source, had been preparing and putting onto the market maybe for the last half year. So that's a general, maybe I want to get your view on that one. How do you see that? So startups preparing ideas, this very creative community, and they do things. And then half a year later comes, I think you can say it in general, big tech, let's put it like that. I'm not going to say bad big tech, and then they take these, and then what does the startup open source do then? Do they restart? Do they survive?
Yeah, but to earn money with open source is a different. I think it's a totally different approach. But I want to say, with this OpenAI marketplace, or how you call it, now they want to earn money. Now they want to make money out of that, and it was very impressive. But you also see a lot of shitty solutions there in this market. So everybody is now playing around. There was a guy who had a GPT to have a better performance on your LinkedIn or something, and that will help you to improve your profile and stuff like that. I tried, but it was shitty. So. No.
Yeah, sure. But that's the way that you deal then with your app store, right? I think, is that the typical difference between the Apple App Store, where, I think humans look at it or whatever, I guess in combination with algorithms. So they certify, let it go through. And I think the Google App Store is not like that. Is that? I'm not sure. Or maybe it is. Maybe it is, yeah. So anyway, a huge announcement, and maybe not everybody was too happy with those announcements, what we'll talk about later. Now, at the same day, we recall, and only you and I, and I guess maybe some of our German listeners. So there was Aleph Alpha. They received 500 million from Bosch, from the Lidl founders, a couple of other companies. It was orchestrated by the government. So Aleph Alpha, maybe you want to say 2-3 words to them, as also large language.
Also large language, trustworthy AI made in Europe. That's their claim.
Exactly.
And we'll do an interview with Dr. Nauertz from Bosch. He's a member of the board of Bosch, and he will explain us why he invested, where's the future of LLMs for Bosch. I think I had a briefing call with him. They will go into small LLMs, specialized LLMs, but we will have a podcast on this topic too.
Good.
But I'm a communication guy. I'm a journalist. You cannot present this big news in Germany or in Europe one day before the OpenAI developer conference.
I think it was the same day.
What the heck is that? Because then you have 10 hours of media coverage, but then everybody is focused on this developer conference.
I was going to say exactly the same thing. I'm not a journalist, but I've been working in communications as well. But I think everybody understands that. So it was celebrated in Germany, the biggest thing, because of course, if you listeners from outside of Europe, you always hear this, Europe is so frustrated and Europe is behind. And at the same time, you will hear always from Robert and from me that we in the industrial AI market in Germany, in Italy, in France, in Europe, that we are very proud of the things that we're doing. So that's a very, very big differentiation we need to make. So here we go. There is the first time 500 million also for, in this case, a German. And we look at a couple of other ones on the European market as well. And it's orchestrated by the government. And then it's celebrated, yes, on German communication channels. But on a global level, it was only Dev Day, right? It was like 99 messages on OpenAI Dev Day. And there was one on, if at all, on, So looking forward to have that one. There was a second one, right? Another second, third one. It was Poro. Do you know what Poro stands for?
It's a reindeer, all right?
Very good. I wasn't sure your Finnish capabilities.
I did my homework. Yeah.
Or was it a quick translation?
No, I did my homework.
Translation.
I did my homework.
So what are they? They are from Silo AI, right?
Yeah. From Finland, right? Not from Helsinki, from Turku or what?
Oh, right. I saw that. Yeah, Turku. I hadn't heard of Turku. So it's a cooperation with the University of Turku.
Yeah, I think so.
They can train on Lumi, all these acronyms. And Lumi I hadn't never heard of. And they say it's Europe's fastest supercomputer.
Yeah.
And it's located in Kajaani in Finland. All these Finnish words. We talked yesterday. You recall I was with Siemens yesterday, and we talked about him as well. And they talked about we talked about the Finnish language, and they said there is a relationship to, is it Romanian? No, Hungarian. For whatever reason, they're not neighbors, but there's a relationship in the language. So that's another open source, large language, multilingual AI capabilities that they're striving for eventually all 24 European languages. So let's see if not only language, because in addition to which Nionic is going to be doing, concentrating very hard, strongly on industry. So that is our big interest. Let's see if in what markets potentially Poro is going to be used.
And I have one more topic, one more company. It's not it's not a company. It's a very special. It's QTI from France. It's a non-profit AI lab dedicated to open science. And we are starting with almost 300 million support. And now what's very interesting, we are super grateful to benefit from the support of our scientific board members, Bernhard Schölkopf from Tübingen and Jan Le Can. Very interesting.
Yeah, so Jan has, I guess, language-wise or country-wise, Jan is a original French guy, right? With Schölkopf. What's his first name?
Yeah, Bernd Schölkopf.
Bernd. Yeah.
Max
I wasn't
Planck.
sure, but it probably works the same way. That one of the guys, girls, persons has probably studied with him. That was my thought. Yeah.
Okay.
The big word here is, what did you say? Non-profit.
Non-profit.
Now, that is the big word. Let's not maybe jump, but I can't share. I know as well. I saw, so in addition to Mistral is the other one of the big ones on the French market. There's now QTI. So we see a couple of these also on the European market, typically open source, now being funded by, in a different way. It's not by big tech or the big VCs on the US market, but it's more like, it's companies in completely different markets, right? Or in this case, Bosch for Aleph Alpha. So in our market, or it's the retail company, that nobody, actually that's not true on the European market, Lidl and the other one as well. So
Aldi, yeah.
Right. So I think that the big word here is non-profit. If we want to move into and close off with our drama, right? So the drama that came, and most of you will have heard about it now, unless you have been spending your time on holiday somewhere very, very far away on an island just by yourself. So Sam got fired, and it's all around the way that OpenAI has been organized as a non-profit organization at the top, and just under it is a for-profit organization. That's what they decided, I think, like 2 years ago, when they realized that they were never, ever going to be able to attract money if they were going to stay at the top of nonprofit exclusively. So, and after they did that, I guess the bottom one, so the for-profit organization, then got the 10 billion from Microsoft, right? And then I haven't still seen the exact clear, but it's all about the divide between on the board level, and in the end, it was this person we just mentioned, the guy that has co-written Alex Ilya Kutskever. I think that's how you pronounce it. Maybe not perfectly correct. And he was, part of the 2-3 other people in the board, which nobody ever has heard of. I must say, don't take it personal if one of you are listening to this. And they decided that, Sam had to leave. So it was about speed. It was about non-profit. It was about AGI. AGI, I mean, Ilya is very strong about this. He is more like a real believer that we're very close to this point where the large language models are going to take over, right? And then the other side, so the SAM side, and Microsoft and of course all the people who kind of want to do business and want to make money, they don't see that. I mean, Sam is not saying, that's bullshit or whatever. I think he is the person who is very careful, but that's where the board strongly disagreed over, and they fired Sam. And then what was next?
It was very fun because I found something very interesting from Sander Hoffman from ASML, and he listed yesterday the most popular articles from The Verge over the past 48 hours. And now I will read out. So number one was Microsoft hires former OpenAI CEO Sam Altman. Second, Sam Altman isn't coming back to OpenAI. It's third, OpenAI board is discussing with Sam Altman to return as CEO. Fourth, hundreds of OpenAI employees threaten to resign and join Microsoft. Fifth, Sam Altman is still trying to return as OpenAI CEO. So it was, it's a soap opera. What a drama.
Not sure it was still even in that order, because even this...
No, it was the most... No, it's not the order. It's not a chronicle, but it's the most read articles on The Verge in the last... But
even now, we're recording this on the European Tuesday morning today. Even now, there is a chance of Sam returning. It's not... I mean, they have now officially a job. He and Greg Brockman have a job with Microsoft.
Yep.
But I understand that there's even potential that whatever. Let's see. I think what is important is that the new CEO is called Emmett Shear. He was the CEO of Amazon, daughter company Twitch, I believe, right?
Twitch, yeah.
Have you seen Twitch? Twitch is this very fast following people on every move they make. Fast YouTube kind of thing, right? I haven't really been following that. Now I'm going to give
you, Peter. You are not the target group on that.
Oh, very good. Thank you very much. So I saw one quote from him. He said, I specifically say, he says, and that was before. It's not, but just understanding of what this is all about. I specifically say, says Emmett Shear, I'm in favor of slowing down, which is sort of like pausing, except it's slowing down. If we're at a speed of 10 right now, a pause is reducing to 0. I think we should aim for a 1 to 2 instead. So that's what this was all about. The board members, including Ilya, which then 2 days later says he's very sorry and he had hoped that he had not voted against Sam. I think it's a little bit too late for that now, but that's what was the
drama.
Base. But it is very interesting. Unless you say, well, anyway, you could say on one hand, I think there's a general feeling that the board has behaved like children, maybe.
Yeah.
What is lacking, I feel, is that I haven't heard them speak out. If there's any articles, topics, I'm very, very much looking forward to hearing from them. On the other hand, I'm sure that they will say, we are the board. We have defined who we are, and we need to stick to what it is that we are. We're a nonprofit. Very, 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 very difficult. And of course, everybody agrees as well that, it's Microsoft's and the other investors' own fault. I mean, they knew that they were giving money to a profit, which was a daughter of a non-profit, and that the non-profit, there were only people who had no financial investment in the profit, and only they could make the decision. So it was very, very, very weird setup. And I think something happened that nobody has ever considered that would happen. Now, life goes on, but it was a real interesting soap opera I've been following for 48 hours, I must say.
Yeah, I woke up at the weekend. I got the notification by Marco Huber that Sam that Sam resigned, and I said, okay, that's interesting. Yeah, that's a big, huge topic, and then the whole drama starts. Yeah, it was. Well, yeah. Thanks, Marco.
So here we are talking large language models again, which I believe is perfectly okay. And if not okay with any of you listeners, always just let us know, Robert at AIpod.de, Peter at AIpod.de.
Oh, we also talked about gray boxes at the beginning.
Anyway, and no, my point is going to be, if that is, we call ourselves industrial AI, and I think that's still perfectly okay as a representation of what it is that we do, and that's if that's your topic as well. At some point in time you could rename it, but that's I think it's bullshit. That's not a proposal I'm making. You'd say industrial LLMs, and most certainly we talk about large language models because that is the hot topic of the day. And then we always look on a wider perspective, and then we're going to zoom in on what can we do in our industrial environment with these large language models.
And now in the main part, no LLMs. We talk about robotics and models of robotics. Very interesting interview with Abhinav Valada from University of Freiburg. Thank you very much, Abhinav. It was a pleasure. So, Peter, you can learn something in the main part about robotics
Exactly.
and the general models of robotics. It was a pleasure. Thank you very much, Peter.
Thank you, Robert. See you soon again. Have a nice day.
Bye-bye.
Bye-bye.
And it's a pleasure to talk to Professor Dr. Abhinav Valada from University of Freiburg. Hello, welcome to the podcast.
Hi, Robert. Great to be here. Thanks for the invitation.
Yeah, we are looking forward because we want to talk about RTX, the model by Deepmind. But before we start with that, please introduce yourself briefly to the listeners, Abhinav.
Yeah, great. So I'm Abhinav Valada. I'm a full professor and director of the Robot Learning Lab at the University of Freiburg. So we're a lab. We work on diverse range of problems in robot learning, ranging from manipulation, mobile manipulation, autonomous driving, and etc.
Yeah. Why were you the only German university involved in the project? How did that come about?
I think that's because some of the PhD students here had some existing collaborations with Google Brain, actually. And some of the co-authors, I think, from the Google side already were in touch. There are many, many great, wonderful researchers in Germany. And I think in this case, it was just because we had some contacts with our partners in Google.
Can you describe a little bit what was the research question?
That's a great question. So the research question is essentially, can we create generalist robot learning models as we have seen in other domains like natural language processing, or more recently, even in computer vision? Can we create these large-scale generalist robot learning models that can then be used for many other tasks downstream? So one of the biggest things that made these large generalist models work in other domains is data, as you can imagine. But if you think about robotics, it's really different.
It's very difficult, right?
Exactly. So because we have diverse types of robots, we have diverse environments that we want to deploy our robots in, we have diverse tasks that we want our robots to do. So to encompass all the possible tasks, all the possible environments, all the types of robots is many permutations of data to collect. Yeah, so as you can imagine, such an effort is only possible if the whole community sort of comes together. And even then, even what we have with these RTX models is nowhere close to what we, really want if we want to create these generalist robot learning models.
But why we should create or generate these models?
Because I think tremendous amount of progress in the last decade in creating task-specific models. And what we have seen in the last few years is we can only get so far with creating task-specific models, because it's really not possible to collect a data set in every possible scenario for every possible task. But that's what we've been doing, and that's what we are doing for application-specific robots, right? So we collect a data set for a specific robot with a specific hardware setup, and it works well. And what we've seen is that this still is not really exploiting the entire capability that we can do if we collect a general data set, as we have seen in other domains. So what this paper, I think, has shown, or what the goal of this paper is to show, is that if we create such a large data set, which is embodiment agnostic with different tasks, it enables us to do better than just training on one specific task with one specific robot.
But why do the general model perform better than this specialized ones?
I think this is like similar to any other domain, because we cap the structure that is there in the data that is more semantically meaningful than just a specialist structure. So if you can think about collecting a data set in one specific environment and deploying it in the same sort of similar environment, then you really capture the specific structure that is there in this construct that we have with the specific robot, the specific environment. But the general nature of the task itself is not so much captured. You can think of it that way. And yeah, that's what we are aiming to do by capturing large amounts of data in different environments. So we don't want to learn environment specific or robot specific information, but rather we want to collect general information about task agnostic, environment agnostic, which then you can exploit better for, one specific task in the end.
You mentioned tasks. What tasks are we talking about? What applications?
So here we specifically, in the RTX models, we specifically deal with manipulation, in the sense that you have a robot arm that's doing a bunch of tasks given language instructions. So this can be things like pick up an apple from the drawer and place it on the counter, or pick up an orange and put it inside a drawer. So these are instructions that we have. And with these instructions, we have images of the robot doing the task. And what we do here to teach the robot to do these tasks is imitation learning. And then the goal is that the robot should basically do the actions that is described in these language instructions.
Can you please describe for our listeners the experimental setup? What was the experimental setup like? How did you proceed? And which robots did you work with?
So here in Freiburg, we have our Franca Panda, which is the manipulator arm.
Oh, it's quite famous in these days, right?
Yeah, it's really, really famous. So we have this setup with, I think we have 2 drawers. We have a sliding door. We have some push buttons. And so this is some work that we have been using for quite some time now with language instructions. And this work was initially done by Oyer Mess and Chengwang Huang, who are 2 PhD students here. And this setup was basically used to collect data in our specific setup in Freiburg. But this is just one out of more than 22 odd setups that's been done by different labs in different parts of the world. And each of them are very, very different. So there are other types of manipulators, but there are also quadruped robots. There are bimanual robots, as in having 2 arms. So this is really, really different types of embodiments, very different types of task setups.
But how do you combine these different setups?
So that's a great question. So one of the goals of this paper was essentially defining a paradigm for collecting data. So this data format in this paper is called RLDS format, that was initially, I think, proposed in a different paper. So the paper was called An Ecosystem to Generate, Share, and Use Dataset in Reinforcement Learning. And this paper initially defines this format, and we adopted this format. And also we stored data in something that's called TF Records, which is database format from Google. And so everybody collected data in this format and stored it in this database. So that's also sort of a definition of data collection that's used by everyone in this paper.
What is so special with this format?
I mean, there are many formats in the literature, like many existing data sets use different formats. I think one reason is because in other domains in reinforcement learning, this has also been more and more used. So it was just easier to adopt in this case because it's sort of converging towards many existing data sets use this. And TF Records is basically a data format that's easily, very fast accessible. It was developed by Google, initially used in TensorFlow, but now it's also used in many other deep learning frameworks.
You mentioned already the results. Did the results surprise you?
Yes, because I think in other domains such as natural language processing or vision, you don't have so much of variation in terms of tasks, modalities, embodiments, environments. So I think in computer vision, if you compare it, you have tasks and you have environments, of course, but now you have another dimension of embodiment. So you have, this just increases the amount of permutation that you have. So I think we definitely had a lot of hope, but did not expect that much improvement considering the amount of data that we have is still not remotely as much as what you have in vision or natural language processing.
How big is this data set? And did you also use synthetic data?
So just to go over the numbers, I think it has over 22 different robots, I think about 500 different skills that amount to over 160,000 different robotic tasks. Those are some of the numbers. And I think the data, it's over 1 million types of trajectories that the robot has, that the robots are performing. So yeah, you can think about it as 1 million trajectories that the arms are moving, over 1 million.
So no synthetic data.
No, in this case, it's all real data.
I want to come back to this transfer because robots are very complex systems. Is it really possible to transfer this general, I would call it baseline model or whatever, foundation model? Please just explain it to me once again. How difficult or how easy is it now to transfer this model to a robot, to a different robot, maybe not to a Franka, maybe to a Yaskawa robot?
So that was the whole premise, that we wanted to prove that this leads to a positive transfer. So what we've seen in the last, I'm sure you must have heard about this concept that's called sim to real.
Yes.
Which is also a problem where you train a robot in simulation, because we can create infinite amount of environments with different robots, different tasks. So we can also collect such a data set in simulation, but then you have this problem of sim to real transfer, in the sense that a simulation is not as accurate as possible as collecting a data set in the real world. So then we have to adapt this model to, a real robot with real physics and real things that the robot has to deal with, which is not modeled in simulation. So in this case, if we collect real data, you don't have this problem of sim to real, but rather you have this problem of adapting from different embodiments. And really that problem is not even tackled here in this work. So in this work, it only collects diverse data and trains. So I think in the future, what you would see is many follow-up works that, try to reduce this domain gap between different robots. There are many techniques in the literature to do this. But here, what we showed that it's even possible to just take all of this data in a general format. And here, Google basically trained 2 of the models that they have existing, and they just trained it on this large data set. And they showed that in one case, it led to, I think to be exact, it was like 50% success. And in the second case, the RT2 model, it led to 3 times better performance than only training on the initial data that they did in their first paper. So this just shows us that collecting real data from diverse embodiments is extremely beneficial.
So you already mentioned vision and you already mentioned ImageNet. Is this the ImageNet moment in robotics?
I would say so. I think this is the beginning of the ImageNet moment. I'm pretty sure that what this work has sparked is just the beginning. And now that we have this format available and we have shown this, the entire world can contribute to this data set. So it doesn't stop here. So anybody can...
Is it open source?
Yeah, exactly. So anybody can, adopt and collect more data with their own robots that they have, and they can add to this data set, and this hopefully would become much larger in the future.
So the idea is to build a foundation model on robotics, right?
Mm-hmm, exactly.
Now our podcast is called Industrial AI Podcast, and we invited you, Abhinav, to talk about this model. But what does it mean now for the robotics companies, this foundation model? Is it a threat or is it a chance for them?
I wouldn't say a threat. I think it's always, if you see something in research, it's always a chance to...
As a researcher, sure.
Exactly, to show what's possible. And I think the industrial use case would be very different from the settings in this data set. So there are some settings where you can apply to, industrial environments, but a lot of these settings are more like home environments or kitchen environments where the tasks are something like cleaning a counter or putting things away. You can also apply them to industrial domains, but I think like definitely this is a chance to show what's possible. And if you think about different industrial settings, I'm pretty sure that this also gives hope to companies that such vision language models for robotics can also be created by industry for their specific domains.
Yeah, I think that's the message. It's difficult to build foundation models on specific industrial domains, but it's possible, right?
Exactly. And I think this is only like tackles this one sort of setting of vision language robotic models, right? So if you think about industry, you also want to create foundation models that include much more diverse modalities. You want, for example, depth information, you want tactile information, and all of this is not really addressed in this work. So it definitely shows you that including more complex modalities is something that we need to do in the future. So it also shows you opportunities that this is possible.
But can I use this model at the baseline to take the next steps?
Yeah, definitely. That's exactly the goal, I think. Definitely, I'm pretty sure in the future we will see other works that come up which use different types of models that are built on top of these models. Let's say so-called fine-tune these RT1X and RT2X models for different tasks and domains. So that's the adaptation is not really addressed in this work. And how to adapt these models is something that will definitely come in the future, that is called like transfer across embodiments. And this will really improve the performance much, much more.
So your advice to the robotics company is watch this carefully.
Definitely.
Yeah.
And work together to improve this much more.
Can you summarize, please, once again, where the model is still maybe lacking? Where do we need still more research on this?
Yeah, that's a great question. So in this, there's a very interesting part of this paper which talks about some of the limitations. So this paper basically does not consider that the robots have different sensing and actuation modalities. This is because the input is just the camera images, the trajectory, and the task description. So it doesn't consider that each of these robots have different sensing modalities. And if you consider this, there's definitely some improvement that we can make. And the study also does not study the generalization to new types of robots. So it only studies the generalization to robots that it has seen during the data collection, but not a different robot that is never seen. So this one aspect is still not touched upon in this work. And it also does not provide any, let's say, decision criteria of what is a positive transfer, or when does this transfer does not happen. So these are some aspects that I think we will definitely see, I'm pretty sure, in the next 1 year. I'm pretty sure there's like researchers all over the world who saw this paper and are working towards these problems right now. But I think these questions are very important to address in the future.
I want to come back to this term foundation model or general model or whatever. I want to talk in general with you. Who owns the foundation model at the end?
Great question. So in this case, the foundation model, I would say there are two models, right? So there's this R1X and R2X. So these models were initially developed by Google. They just trained it on the data. So these existing models were just trained on the data set. This was collected from different people. So I guess the model itself, it's not a new model that came out of this paper. So I would say that models are R1X and R2X are from Google. But again, if you have a different model, so there's nothing special in this model that it makes the foundation model, but only the fact that it's trained on these diverse data. So there are many models like this, and we can train any of the existing models also on this data set and make it more open source for different tasks. And I'm sure this will happen in this coming months.
So everybody can use the model and train it with their own data?
Exactly.
But that's a big point, I think.
But one question again is we need a lot of compute to do this. But I think that this is definitely possible.
What are your next tasks in your department, Abhinav? What are your next tasks in robotics and AI?
So one of the things that we're really working on is to, as I mentioned very briefly before, is to scale this with different modalities. Vision is great, and we need vision to see what the robot has to do in the world. But I think we definitely need more modalities. We need, for example, depth information to see how far the objects are around in the environment, what the robot shouldn't collide with in the environment. But we also need other modalities such as tactile sensing data. So when a robot is grasping an object and doing things with this object in hand, the tactile information is very, very useful. So we are working towards integrating more diverse modalities and to create, let's say, like a foundation model with diverse modalities beyond just vision and language. And we truly believe that this will further improve the capabilities of robots in the future.
At the beginning, I asked you why you are the only Germans in the project. And now I ask you at the end, what is our position in the robotics AI world from a European point of view? What is your opinion on that in research and when you combine it with all your colleagues in the US?
So I think there are truly many labs in Germany that are on the forefront of robot learning. And many of these labs are doing very great things that are, I would say, even beyond, much beyond in different domains than what you might see in industry, in Google or other companies. And I think this is one domain where we are, let's say, on par, even better than many places. And I think this has a long history of having very strong engineering background in Germany. Yeah.
Okay. So do you think is research coming back to the universities because Google and the other big tech companies do not want to share anymore all their results? What is your opinion on that?
So I think research never left academia. So there are some domains where we have seen industry get involved much more, but there are some domains where industry doesn't really do research on. And this again, industry does research because they see a direct application to products, right? They still don't do entirely open blue sky research, which is only possible in academia. And we've seen some really great things from industry pushing forward certain domains. This has also helped us do more research in different directions, even in academia. I think like some industries also open source their research that they do, not necessarily for commercialization purposes, but for research, they still let their code open source, further develop on this.
But is it easier for you now to find PhDs maybe in the future?
Well, it's always a challenge. And I think the way to attract talent is to show them that truly interesting blue sky research is only possible in academia. We have the freedom to do this. We're not, let's say,
dependable on money,
depending on product teams that want tangible products out of this. I think like this is still only possible in academia.
Abhinav, it was a pleasure. Thank you very much for explaining us the RTX model by Deepmind and your role from the University of Freiburg. Thank you very much. It was a pleasure.
Thanks a lot, Robert. It was great talking to you.